This is Edexcel Secure Mock 3, paper 3F. Question 1. 3/5 of people at a tennis club are women, the rest are men, so what fraction are men? Well, if it's 3 out of 5 women, there must be 2 out of 5 that are men. Change 350 centimetres into metres. We need to know there's 100 centimetres in a metre, so we divide by 100, and that will give us 3.5 metres. Here's a list of fractions. One of them is not equivalent to a third. So to find equivalent fractions, we multiply top and bottom by the same number. So this one we've times top and bottom by 3, this one we've times top and bottom by 5, this one we've times top and bottom by 7, this one we've times the top by 9, but 9 times 3 is 27, so this is the odd one out. So it's 9/30. Question 4. One evening the temperature was -7 degrees C. By midnight the temperature dropped by 5. What was the temperature? So you're down at -7 and you're going to go down another 5 down to -12 degrees C. Question 5. Here is part of a train timetable from Lostock to Preston. How long should the 7:46 train take to go from Lostock to Buckshaw? So Lostock at 7:46, going down to Buckshaw gets there at 8:06. Now a lot of people try and take these two away using the column method, but that presumes it's 100 minutes in an hour, there's not this 60. So we have to do this by working up from there up to 8 o'clock, which will be 14 minutes up to 8 o'clock, and from 8 o'clock up to 6 minutes past will be another 6, so that will be 20 minutes. Ariz wants to go from Horwich to Leyland by train. He gets to the train station at Horwich at 8:30. What is the earliest time he can get to Leyland? So he gets to Horwich at 8:30, so he misses these two trains. This is the earliest train he can get, but if you look down here, this train does not stop at Leyland, so he can't get this train. So the earliest train he can get is the 8:51, which stops at Leyland at 9:12. So the answer is 9:12. Mike wants to go from Blackrod to Preston by train. He needs to get to Preston by 9:25. What's the latest train he can get from Blackrod? So if he wants to get to Preston by 9:25, all of these trains will get in there by that time. So if we look at the latest one, this one does not stop at Blackrod. So we're not going to be able to catch this train. So the earliest one he can get, we'll get in there at 9:17, and that would be 8:53. So 8:53 is the latest he can set off. Question 6. 1 kilogram is 2.2 pounds. Change 319 pounds to kilograms. Well, there are 2.2 pounds for every kilogram. So if we divide this by 2.2, again you could just use your calculator, you get 145 kilograms. Question 7. Mary, Bianca and Steve are picking apples. Mary picks 264 apples, a sixth are green. Bianca 150 and 28% are green. Steve 340 and 15% are green. Who picks the most green apples? So look at Mary first. So Mary picks 264 and a sixth of these are green. So we need to divide by the bottom times by the top. So divide by 6 and then times by 1, but we don't need to do that because it's just 1. So if we do that on our calculator you should get 44. Bianca picked 150 apples. And 28% of those, so 0.28 is 28% as a decimal, or you could times by 28 and divide by 100, that's fine, and that will give you 42 green apples. And then Steve picked 340 and only 15% of those, or 0.15. Again, you can times by 15, divide by 100 if you prefer, and that will give you 51 apples. So Steve picked the most green apples. Question 8. Sharon asked each of her friends to name their favourite Olympic sport. The table below shows information about their answers. Draw an accurate pie chart for this information. Well, the first thing we need to know is how many people did she ask. So if we add these up, she asked 45 people. There are 360 degrees in a circle, so 360 divided by 45 equals 8 degrees per person. So if we times each of these by 8, we'll get the degrees for the section of the pie chart we need. So this would be 104. This would be 136, this would be 64, and this would be 56. And just to check, we add those up, we get 360, so we're correct. To draw this in your pie chart then, we need to use a protractor. So we line our protractor up, the centre of the protractor will go right on the centre of that line. The first one is at 104 degrees, so you're going to go down to 104, and as accurate as you can, you're going to put a point. So that will be just there. We can then just move our protractor to one side for 1 second. We're going to draw a line then from the centre, which is just here, through our mark. So that gives us that line that we need for that section. We then need to label up our section. So this is 104 degrees, and this was for athletics. So really important that you label your pie chart. Next, we're going to line our protractor up with that line that we've just drawn. So really, really accurately line that up. And the next section needs to be 136 degrees. So follow it around from 0 again, round to 136 would be just there. So again, get rid of our protractor and put our line in. And again, from the centre to our mark, doesn't matter that you're going outside the circle, it's making sure that our measurements are correct. So that will be 136 degrees, and that is for cycling. Make sure we're labeling it up properly. We then go back to our protractor. This time we need it on the line that we've just drawn. So we're going to line it up in the centre, and we're going to spin that round so it's on the line that we've just drawn, accurately as you can. The next one needs to be at 64 degrees, so start at 0 again. We're going to go around to 64, which will be just there, as accurate as you can. And now we can get rid of this and draw our last line in. This is going to be our last line because the last section will be drawn for us then. So again, draw it up to our mark. Okay. This last section, last two sections, sorry, was 64 degrees. That was for swimming. And the very last section was 56 degrees, and that was for gymnastics. Make sure you're as accurate as you possibly can on each of these. Question 9. Here is a number machine. Find the output when the input is 6. So 6 times 6 is 36. And then add to 7 would give you 43. Find the output when the input is minus 4. So 6 times minus 4. And then add on the 7. 6 times minus 4 is minus 24. Add the 7 is minus 17. And find the input when the output is 79. So we need to do the opposite. We're going to start with 79. We're going to take 7 off. And then we're going to divide by 6. So that'd be 72 divided by 6, which would be 12. It says 400 grams of raspberries and 300 grams of strawberries cost a total of £7.46. 500 grams of strawberries cost £4.10. Work out the cost of 200 grams of raspberries and 200 grams of strawberries. Well, first of all, I'm going to use this fact here to work out what 100 grams of strawberries would be. So £4.10 divided by 5 would give us 82 pence for 100 grams of strawberries. Once we know that, we can use that to work out the cost of some raspberries. So we know that 400 grams of raspberries plus 3 lots of 82p would equal the £7.46 because 300 grams at 82p a gram for the strawberries. So if we do £7.46, take away the 3 lots of 82, we get left with 400 grams of raspberries equals £5. So if we divide £5 by 4, we get 100 grams of raspberries is £1.25. So we've got our prices now, 100 grams of raspberries and 100 grams of strawberries. Once we've got that, we can put it in. So 200 grams of strawberries, we're going to do 2 lots, sorry, raspberries will be 2 lots of £1.25. And our 200 grams of strawberries will be 2 lots of 82p. And again, we can just put that in our calculator, we get £4.14. Question 11. Describe fully the single transformation that maps C onto D. So we're going from C to D. Now we can see it's not been rotated, it's not been reflected, it's not been enlarged. So it must be a translation. A translation is where the shape simply moves. Alright, it doesn't change orientation. So this shape, if I choose this point here, has gone 1, 2 up and 1, 2, 3, 4 to the right. So we're going to do a vector. The top number is left and right, so it went 4 right, so it plus 4 on the top, and it went 2 up, so it would be 2 plus 2 on the bottom. If it was left or down, those would be negative. It says put a pair of brackets in each statement to make the statement true. So 2 times 7 squared take 2 equals 94. So at the minute we would do 7 squared is 49, times by 2 is 98, take 2 is 96. So we want to do the 7 squared, take 2 first. So 49 take 2 will give you 47, and times 2 will be 94. So that's where the brackets need to be. On this one, at the minute we'll do 16 divided by 2 is 8, then add your 6 is 14, and add your 2 is 16. So we need to do something to make this much smaller. So we need to do 18 divided by 2 add 6, because 2 add 6 is 8. So 18 divided by 8 is 2, add your 2 would be 4. So we need brackets around the 2 and the 6. Question 13. Here's a shape made from a rectangle and a triangle. Work out the total area. Well, the rectangle is quite easy. We just do 9 times 15. We could do that on our calculator. So 9 times 15 is 135. And then the triangle, if this is 7 and the full width is 15, that means that this must be 8 here. And if the full width here is 22 and that's 9, then this must be 13 here. So we need to do 8 times 13 and half it, because you do base times height divided by 2, and that will give us 52. So the area of the triangle is 52. So 135 add 52 gives us 187. And you can see that the centimetre squared is already in the answer line, so there'll be no mark for that, 187. Question 14. On the grid, draw the graph of y equals 2x minus 2 from minus 3 to 3. All this bit means is that your line needs to go past minus 3 on the x-axis and past 3 on the x-axis. So it needs to be a full line. Now, a lot of people think that that means that you have to draw the table from minus 3 to 3. But you don't need to draw a table at all. So if we were going to draw a table, I would perhaps just do 0, 1 and 2. Just do a few points. You don't need to do all of them. But I'm going to use this using y equals mx plus c. So the m stands for the gradient, and the c stands for the y-intercept. So on this one, the y-intercept is at minus 2. So the y-axis, this line is going to cross at minus 2. And then a gradient of 2 means that for every one across, you go 2 up. So just got to be careful with the axes here. So to go 1 across is actually 2 squares, because you've got to go get across to 1. Then you've got to go up 2. Across 1, up 2. Across 1, up 2. So our line would just be through all of these points here. Question 15. Work out 4.36 plus 2.8 cubed divided by 6.8 minus 5.42. Now, the best way to do this is to use your calculator and use your calculator's fraction button. So you can put a fraction in there, which is this button here, and then we can just do 4.36, add on to that 2.8, and then to do cubed, we use this button here and put a 3 in. We can then press the across button to get onto the bottom, and that would be 6.8, take away 5.42, and this should just give us the answer, but it will always give us in a fraction, so we need to go into decimal, which will be 19.06 recurring. So 19.06 recurring, like that. It says write down all the digits on your calculator, and then give your answer to correct to 1 decimal place, that will be 19.1. Question 16. The table shows information about the number of children in each of 40 families. Find the median number of children. Well, there are 40 families, so we need to find the 20th family to find out how many people in that family, how many children are in that family. So there's 6 families with none, there's 13 families, so that's 19 altogether. So in this section there are 19 families. So the 20th family must be in here. So the 20th family must have 2 children. It says work out the total number of children. Well, there are 6 families with no children, so that's nothing. There are 13 families with 1, so that's 13. 12 families with 2, so that's 24. 7 families with 3, that's 21. 2 families with 4, so that's 8 children. And 0 families with more than 5. So add these up, we get 66 children in total. Question 17a. Expand 2a brackets a plus 7. Well, 2a times a would give us 2a squared, because a times a is a squared. And 7 times 2a would give us 14a. So 7 lots of 2a's would be 14a's. Factorise 14b minus 7. Well, 7 goes into both of these. So I can pull a 7 out, and I need to times it by 2b to get back to 14b. And I need to times it by 1 to get back to 7. Solve 9 brackets c minus 6 equals 63. Well, normally I would encourage you to expand the brackets, but we end up with quite big numbers there where we can make mistakes. But we notice here that 63 can be divided by 9. Now this means times by 9, so to divide by 9, I would end up with just that. And then I can add the 6 to both sides, and I get that C must be 13. Simplify 3y squared times 4y cubed. So all this means is 3 times 4 times y squared times y cubed. Now 3 times 4 is 12. We can rearrange this because multiplication doesn't matter which way around you do the numbers. So 3 times 4 is 12. Y squared means y times y times y times y times y. So we're going to have 5 y's all in a row, or y to the power of 5. Question 18. Claire buys a new car for £5,700. She pays a deposit of 12%. She then pays the rest off in 15 equal monthly payments. How much is each monthly payment? Well, to work out 12%, we do 5,700 times by 0.12. Or, like I said earlier, you can do times by 12 divided by 100 to work out percentage, which gives you £684. So a deposit is 684. We can then take that off, so 5,700, take off the 684, that will give us £5,016 she's got left to pay. Now she needs to divide that up into 15 equal monthly payments, so divide that by 15, and you get that each monthly payment is 334.4, not forgetting that 0.4 means 40 pence, so £334 and 40 pence. Question 19a, write 168 as a product of prime factors. So this means to do a fact tree. So 168, we can break that down into 2 times 84, which would be 2 times 42, which would be 2 times 21, which would be 3 times 7. So we've got 2 cubed times 3 times 7. So let's find the highest common factor of 168 and 180. Well, to do this, we need the prime factor decomposition of 180. So that would be 2 times 90, which is 2 times 45, which is 9 times 5, and 9 is 3 times 3. So 180 is 2 times 2 times 3 times 3 times 5. Now to do this, we put it in a Venn diagram, and the highest common factors are the numbers in the middle. So if we put 168 on the left and 180 on the right, each one of them has at least 2 2's in it. So we could put 2 2's in it, and they also have 1 3 in it. Now 168 has another 2 in it, and a 7, so that goes in there. And 180 has another 3 and another 5. Now these don't really matter because the only number after are the ones in the middle. So 2 times 2 times 3 is 12 for the highest common factor. Question 20. Both Eric and Geraldine left town A at 2 o'clock. Eric drove on route 1. He got to town B at 2:48, and Geraldine drove on route 2 and got there at 3:25. Who had the greatest average speed? Well, we've got to be really careful when we're talking with, remember, we are calculating with time. There are only 60 minutes in an hour, so just using a calculator with time is really difficult. We either have to work in minutes, or we've got to work in hours, but make sure the decimal is correct. All right. So Eric took 48 minutes, and his route was 36.4 miles. So I'm going to do 36.4 divided by 48. That'll tell me how many miles he covers each minute. And to get that into miles per hour, I need to times by 60 because there's 60 minutes in an hour. So that will be 45.5 miles per hour. And then Geraldine, she took an hour and 25. Now that's 85 minutes. Be really, really careful. You've got to make sure they get that bit right. And she did 65.2 miles in those 85 minutes. And again, to get into miles per hour times by 60, which will give me 46.0 miles per hour. So Geraldine had the highest average speed. We'll just need to write Geraldine. Question 21. It says, here is an accurate scale drawing of a school playground. 1 centimetre represents 2 metres. Nazim is going to put a seat in the playground that it has to be less than 9 metres from C. So C is here. And with our scale of 1 centimetre being 2 metres, 9 metres would be 4.5 centimetres. It has to be closer to BC than AB, so it has to be closer to this line than this line. So we're going to have to do an angle bisector to find where this line down the middle goes. And more than 4 metres from AB, so AB is this line, so 4 metres would be 2 centimetres on here. So, first things first, we're going to look at the distance away from C first. So we need our compass to be at 4 centimetres, so, sorry, 4.5 centimetres. So we're going to open that as accurate as I can to 4.5 centimetres. we're going to place our compass there, and then we need to draw from here around. So this would be our 4.5 centimetres away from C. To do the angle bisector, we need to put our compass at B. We could drag it in a little bit smaller. And what we're going to do is we're going to cut off over here, and then we're going to place our compass at this point here, and we're going to do an arc out here. And then we're going to place our compass here, and we're going to draw an arc here. Now where these cross is where the angle bisector will be. So nice and neatly, we're going to go down here through this point here. So that's our angle bisector. And then to be more than 2 centimetres away from, so we'll move that the other way around. So more than 2 centimetres away from AB, we're going to put a mark here, and a mark here. And again, use your ruler really, but just for ease, I'm going to go across here. So we've got to be further away, so we've got to be this side of this line, we've got to be within this arc, and we've got to be closer to BC than AB. So it's this area here that we're after, all the way around here. Question 22. There are only red counters, blue counters and green counters in a bag. The number of red counters to the number of blue counters to the number of green counters in the ratio 1 to 3 to 7. Fill in the probabilities. Well, probability must be in a fraction, a decimal or a percentage. So there are 11 counters altogether. So it's 1 out of 11, 3 out of 11 and 7 out of 11. It says Jamie takes at random a counter from the bag and records the colour of the counter. He then puts the counter back in the bag. Jamie does this a number of times and records a total of 68 blue counters. Work out an estimate for the total number of counters he took from the bag. Well, 3/11ths of them are blue, so 3/11ths must be these 68 counters. So to work out how many in total, we need to work out what 1/11th is by doing 68 divided by 3, and that will give us 22.6 recurring. And then 11/11ths would be 22.6 recurring times 11, which gives us 249.3 recurring. Now, we can either put 249, or we can say that because it's gone over 249, we'll put 250. Either answer is acceptable. Question 23. Mariam is trying to expand and simplify n minus 2 squared. Here is a working. Mariam's answer is wrong. Find Mariam's mistake. So this bit is correct. N minus 2 squared does mean this, so that's correct. She's then done n times n is n squared, so that's okay. Minus 2n, minus another 2n. Well then minus 2 times minus 2 should have been plus 4. So I'm going to circle her mistake, and I'm going to explain that negative 2 times negative 2 should have been plus 4. It says Josh is trying to factorise x squared minus 6x plus 8. His reasoning is, because 4 times 2 is 8 and 4 plus 2 is 6, then it must factorise to that. Explain what's wrong with his reasoning. Well, this bit is correct. We are looking for 2 numbers at times together to give 8, because it's this number on the end. But we should be looking for 2 numbers that add together to give minus 6. So I'm going to circle this bit, because that's where his mistake is. And he should be looking for 2 numbers that add to give minus 6, not 6. Part C, it says Shauna has to draw a line with the equation y equals 3x plus 2. Here's a line. Explain why Shauna's line cannot be correct. Well, like we were looking at earlier, we've got y equals mx plus c, where m is the gradient, and c is the y-intercept. So, looking at this, we can't really do anything with the gradient because we don't know any numbers on the axes, but we do know that the y-intercept should be at plus 2, and the y-intercept is actually at negatives. So all we need to do is we need to write that the y-intercept is negative, and it should be at plus 2. Question 24. The diagram shows a quadrilateral JKLM. Work out the size of angle KLM. So it's this angle here that we're after. So I'm going to call that X. We're going to have to use Pythagoras or trigonometry because we've got right angled triangles here. It's definitely going to be using trigonometry because we're after an angle, but we could be using Pythagoras here because we do need an extra side in this triangle here to be able to work out this angle. So I need this side here. I'm going to call that Y, and I can use Pythagoras to work that out. So Pythagoras says that Y squared is equal to 4.5 squared plus 7 squared. So Y is going to be the square root of 4.5 squared plus 7 squared, which gives me 8.32 ... Leave that in your calculator to use in a minute. So now we know what Y is. To work out X, we know that we're going to be using the opposite and the hypotenuse. So in trigonometry, SOHCAHTOA says that the opposite and the hypotenuse is using sin. So we're going to do sin Y is equal to the opposite, which is this 8.32, leaving this in your calculator, divided by the hypotenuse, which is 15. So to work out Y, we're going to do sin to the minus 1 of 8.32 with all those numbers in, divided by 15. You shouldn't have had to re-put that in because you should have left it in your calculator. And that gives us 33.695 and so on. But it has three significant figures. So three significant figures is just up to there, but the 9 means it will round up, so it'll be 33.7 degrees. Question 25. Neil bought a house for 235,000. In the first year, the value of the house depreciated by 4%, and each of years 2 and 3, the value increased by 6%. Work out the value of the house at the end of year 3. So he paid 235,000. It fell by 4%. So we need to find 96% of its value to find out what it's if we knocked off 4%. And then to increase it by 6%, you times by 1.06, and then 1.06 again for the third year. So if you put all that into your calculator, you'll get £253,484.16. Question 26. Write 2.673 times 10 to the power 4 as an ordinary number. Well, this just means times it by 10 4 times. So you end up with 26730. Write 0.0704 in standard form. Well, standard form must be a number between 1 and 10 times by 10 to the power of something. So we're going to go 1, 2 places. We need to divide by 10 twice. And that will give us 7.04 times 10 to the minus 2. So because it's a minus, that means we're going to divide by 10 rather than times by 10. It says calculate 4.515 times 10 to the 6 divided by 3.01 times 10 to the minus 2. You should simply put all that in your calculator and you should get 1.5 times 10 to the power of 8. Question 27. Here are 4 graphs. Each of the equations in the table is the equation of one of the graphs. Complete the table. Well, the first one we're going to look at is graph A, because graph A is a linear graph and it's positive, got a positive gradient. So looking at each of these, the one that's linear are these two, and the one that's positive x is this one here, isn't it? So we're going to put graph A must be that one. The other linear one, which has got a negative gradient, must be, this has got a negative gradient because it's got a minus 2x, so this one must be D. The next one I'm most familiar with is graph B. So this is a parabola, which is a quadratic graph, so an x squared graph. So this one here must be graph B. And then the final one, the reciprocal graph, we should be fairly used to as well, is graph C.